So let's just talk about different rotations of the AVL tree. So we have the RR rotation, we have LL rotation, we have the right left and left right rotation. So we're going to talk about all of these rotations. So before that we should know about the balance factor. So balance factor of one node is the difference between the height of the left subtree minus the height of the right subtree. Like an example, suppose we have one tree. So here the balance factor for the node 1 will be the height of the left subtree, which is 1, and the height of the right subtree. So 1 minus 1, which is 0. The leaf nodes will have the balance factor of 0. So when the balance factor of any node is 0, 1 or negative 1, then we're gonna say that node is balanced. So that means here all of the nodes are balanced. So we can say that our tree is completely balanced. So the objective of having one balanced tree is to have the tree with the minimal height, because tree with less height is more efficient. So when the tree is well balanced, then our complexity will be order of log n. But in case our tree is not balanced, so in case of the skew tree, we're gonna have the complexity of order of n. So this is huge difference in their complexity. So we can perform all of the operations very efficiently if we have one balanced tree, so that the height of the tree is minimal. Now to balance one tree, we can use all of these different rotations. So first of all, let's just talk about this RR rotation. So suppose we have the values 10, 20 and 30. So that means in the tree, first of all we have 10, then on the right side we're going to have 20, then on the right side we're going to have 30. Now we have to check if the tree is balanced or not using the balance factor. So here the node 30 has the balance factor of 0, the node 20 has the balance factor of 0 minus 1, which is negative 1, so that means it is also balanced. But in case of the node 10, the balance factor is 0 minus 2, which is negative 2. So that means the node 10 is not balanced. So here we have the right unbalancing. Now to balance this, we have to rotate that tree anti-clockwise. So if we rotate this anti-clockwise, first of all we're going to have 20, on the left side we're going to have 10, and then on the right side we're going to have 30. And now you can see all the nodes are balanced. So this is the right rotation. Next we have the LL rotation. So in case of the LL rotation, so suppose we have 30, 20 and 10. So that means first of all we are going to have 30, then on the left side we are going to have 20, and then on the left side we are going to have 10. So now if we check the balance factor, so the leaf node has the balance factor of 0, the node 20 will have the balance factor of 1 minus 0, which is 1, so that means it is also balanced. For the node 30, the balance factor is 2 minus 0, which is 2. So clearly the node 30 is not balanced. So here we have the left unbalancing. So to balance that, we have to rotate this clockwise rotation. So if we rotate this clockwise, so that means 20 will be the root, then on the left side we're going to have 10, and then on the right side we're going to have 30. And now you can see all the nodes are perfectly balanced. So this is about the LL rotation. So let's now talk about the left right rotation. So suppose we have the values like 30, 10 and 20. So that means 30 will be the root node, then on the left side we're going to have 10, and then on the right side we're going to have 20. So if we check balance factor of each of these nodes, node 20 has the balance factor of 0, node 10 has the balance factor of 0 minus 1, which is negative 1, so that means it is also balanced. Node 30 has the balance factor of 2 minus 0, which is 2, so that means node 30 is not balanced. So here we have the left right unbalancing. Now to balance this tree, first of all we have to convert from LR rotation to LL rotation. So that means here we have to perform one anti-clockwise rotation. So if we perform the rotation, you can see 20 will come here, and then 10 will go at the bottom. So now you can see we have this LL rotation. So that means you're going to follow this LL rotation rule. So that means we have to rotate this clockwise. So if we rotate this clockwise, so 20 will be the root node, and then on the left side we're gonna have 10, and then 30 will go on the right side. So now you can see all the nodes are perfectly balanced. So this is about the left right rotation. So let's now talk about the right left rotation. So suppose we have the nodes as 10, 30 and 20. So 10 will be the root node, then on the right side we're gonna have 30, and then on the left side we're gonna have 20. So if we check the balance factor, the node 20 has the balance factor of 0, the node 30 has the balance factor of 1 minus 0, which is 1, so that means it is balanced. The node 10 has the balance factor of 0 minus 2, which is negative 2, so that means the node 10 is not balanced. So here we have the right left unbalanced. Now to balance this, first of all we have to convert the RL to the RR. So that means here we have to perform one clockwise rotation. So if we perform the rotation, 10 will be there, but 20 will go up and 30 will go on the right side. So we have converted to the right rotation. Now to balance this right unbalance, we have to rotate this anti-clockwise. So if we rotate this, 20 will be the root node, and then on the left side 10 will be there, and then on the right side we're gonna have 30. So now all the nodes are perfectly balanced. So this is about the right left rotation. So these are all the different rotations that we can use to balance the AVL tree. So hope you understand the concept. See you in the next one. Take care.